little more challenging, not like it is.
So it's about one. Let's be the point.
Module 2.
Do this.
We don't want to.
What's that? 4?
Yeah.
But that's 4 physics only.
Four?
Yeah, get a mal up.
Four.
I don't know. Jadi kan dulu.
I want to know why I didn't. Right, fair enough, fine.
Yeah, well, you all prove this formula now, right? Simple harmonic motion.
But we have to talk in
Alright, so let's take a look at the upper arm, right? Alright, ready? Alright. So the upper arm is really is a transistor, but not doing transistors now, right? So we just going to focus on one application, a transistor, which is a upper arm. Real simple. What does an amplifier mean? Amplify.
It is
Make louder, right? So if you look at that diagram there, it basically explains what we do. We're taking a quiet sound, right, as the input, it's going through the amplifier and getting something louder, right? Taking a small voltage and the amplifier into a larger voltage. Okay, right? That's basically what the amplifier will do, right? And you just have to make sure that the amplifier working properly, which means it's not saturated. And we have to find a way to calculate how loud it's going to be, which is called Q. All right? We have the concept that we have to learn, right? So I'm going to call out this note for you, it'll be in the handout, right? This first section aims to provide an introductory study of the analog electronics, right? It deals with the switching and amplifying circuits using integrated circuit called an operational amplifier. The operational amplifier, right, gained its strange name because it's originally designed to perform mathematical operations such as addition, multiplication, and it's integrated in devices, now obsolete because we don't really use it, called analog computers. Nowadays, the op-amp is a cheap, mass-produced basic component which is utilized widely in a variety of ways to build systems that process analog signals, right? And it's a little intro into it, right? The integrated circuit, like an op-amp, may contain transistors, right? So that's one of the uses of it to build this, capacitors and resistors. Okay, so all of those combined, you're look at a like a chip, and you see all of those components on it. Right, all those components are transistors and capacitors and resistors. And based on how you connect them, right, you'll have a different component, right? But in this course, we shall not be concerned with the physics or of these components. Instead, we will focus on the way in which the op-amp is connected to produce the desired output. Sometimes it is called the systems approach to electronics, because the emphasis is on the electronic system on what the electronic system does to an incoming signal rather than how it does it. This approach is summarized right down here. Right. So if you look down here in figure 2, it shows you how small it is. That's supposed to be a finger, and it shows you how small the transistor is. Right? And you just put it onto something called a breadboard. You never used a breadboard before. Just like a circuit board, and you just put it on top like Lego. Like a Lego board, and you put Lego figures on top. Yeah, the little green thing, and then just put everything on top of it. We're kind of hoping to get some this year, so it might see like an October. Right. Figure 2 below shows an op-amp chip. Alongside it is a labeled diagram of its connections. Note that the chip requires a dual rate power. So here's what it's saying, right? What you're going to see in our diagram is a railing. Within that railing, power is being supplied. But you could connect, like there are holes here. You could connect at different points to get different values. For example, if here is 20 volts, here might be 0 volts, right? If you connect a wire here at this point, so let's say here, let's pretend that's halfway, then it's 10 volts. Okay? If you connect it all the way to the top, that'll be 20 volts, right? Right? Then sometimes you will see a reading like this. they have opposite polarities. Here is 20 and the bottom is minus 20. Right? So if I connect at minus 20 and at 10 volts, what will be the power being supplied?
Minus 10.
So you're connecting at minus 20 and you're connecting at 10. What do you think is the whole supply? What do you think is the total voltage I gathered in? Minus 10? Okay.
Yes.
Okay, if you connect 20 to minus 20,
Zero.
so you're not getting nothing then.
You'll get 24, you'll get 20 volts.
40 volts. Right? Because the potential difference is the higher minus the lower. So 40 volts become available, right? So what will be available here? 30. 10 minus 20. Minus 12. 10 minus 20. Right? So you'll end up with 30 basically range. Basically. Right, but do those diagrams here, we're not too concerned with that, right? We are concerned with this little triangle here. Right? This little triangle here is the circuit diagram that we're going to use to represent the upper. Right? But here it has a few components that are important. Number one, you have a triangle and you have a negative supply and a positive supply. Right? The supply tells you, Aaron, the supply tells you what is the highest possible output that you can get. Right? So this is the highest possible output, and this is the lowest possible output that you can get. Okay? You cannot amplify input more than those two values. Okay? Then you have two types of input, inverting input. What that means is that if I give you an input as negative, the output will invert it. Right? If I give you an input that's positive and it goes into the non-inverting, it stays positive. Right? So it's important you understand which type of input we're using, right? What's happening with the inverting again, Shivish? What do you think inverted means? Right. So the positive become negative or the negative become positive. Right? More formally, a diagram will look like this. All right? That's what a diagram will look like. Notice the supply, this symbol is in Earth. So that's like 0 volts. Right? Your positive symbol here means your non-inverted terminal that's connected to Earth. And you have an inverted terminal, right? That's where your input going. You see that? So your circuit diagram will look like that. Right? You have two terminals, yeah? Yeah. I'm going over again. Right? So I'm going over again. Most important is the supply. That's what being supplied. Okay? Your inputs inverting. The input is connected here, and in non-inverting, we're not connected anything to it. Just we're connected to 0 volts, right? So that value is always 0. Right? All we're changing is the value that goes into the inverting terminal. Right? And then the outputs, well, you'll be able to measure your output coming out from there. Right? So that is the circuit diagram. Now, how do we know how much the amplification is? There's a term called gain. Gain tells us how much we're going to amplify the input. And to find it, take the output value and then divide it by the input value. That'll give you a gain. No SI unit, right? Gains are very large. Right? These circuit gains are very large. Okay? So that's what it's saying here, right? The most basic function of an op-amp, of course, is amplification. What's the most basic function of the op-amp? So I'm not facing 100. I can with 5 words. The basic function of an op-amp is amplification. That is the processing a signal so that the output value is larger than the input, and the voltage gain is defined by this, right? I want you to make a little summary as it go along. This is very important. Right on the gain. Huh? Yeah. Topic is upper. Already have the handout. I want you to write down how to find gain. Write down how to find gain and then draw this circuit underneath it. Draw this circuit. Maybe not. Right then, write out the find gain, right? And then draw this circle. Yeah, the data compounded.
So it's gonna be that.
What that?
But I just.
That is rearranging the formula. V out and gain and V in. Yeah, the right formula, draw this circle. Right, in your circuit, you have to remember a few things.
That makes sense. I have all my notes.
Maybe, yeah.
Vamos a hacer, a planeta lo hace. I guess you can say exactly that planeta lo hace. Yeah, exactly. What's on the you're being right.
No.
So you put your class in right. Outside.
Yeah, I've done nothing over. Now, but then I follow, that's into the unit for that.
You had a last.
And, huh? That doesn't monitor how my device. It's a sunrise on my device.
I mean, that. We don't have one.
You could play any auto.
No, that was seen from the people of, yeah, you can, it's perfect.
You know, I try to teach all girls, fine, yes. I was in, yes, I have a.
They don't obstruct the sun, right?
That's right, I, sorry, I know, I was thinking, I was that. Gosh, every time I ask about it, I'm always having. I think you get out of set.
Experience.
Well, bad place. So next week, what is it like? What is it? Yeah, we got the show.
Yes.
It's looking at it.
One more time, you finish last one.
Yeah.
We got where again? We got beginning that area.
Tell people I was in class.
All right, come to what?
Yeah.
You ready, Thomas?
Yeah. Same like, I mean,
So we didn't do that. This is a class. This is gonna be our class.
Oh, you were high, that's like.
it was.
Don't worry.
No, I have to play. But I'm just
No.
Yes, she had a computer I can do. See that.
Right, when you're done, just rearrange your phone and put V out. Fine, yeah, V out is what? Huh?
So where's movie?
Huh? OP?
Oh,
That's symbolic to it, right? Zero.
Yeah. Green lights. Yeah.
Anybody writing?
Yeah.
Right? So the output. If I choose wanting to teach.
Depends, reading class.
Yeah.
But then what's he moving like that?
Alright. So sometimes you need to be able to calculate the output, right? And you see this gain here, you'll recognize that I have a little symbol, A0. This is called open loop gain. What it means is this. Open loop means that, well, let me show you what closed loop is. Closed loop is when the output going back to the input. Right? But this circuit doesn't have that connection. So we call this an open loop connection or open loop gain. Yeah, output connected to the input. Right? So if you look here, gain is output over input, right? And the output of an open loop amplifier, that's the example that we have there. So write open loop amplifier. The output of the open loop amplifier, sorry. The output of the open loop amplifier can be calculated using V out is equal to gain by V in. Right? For typical op amp with no feedback, right? The gain will be as high as 10 to the power 6, meaning that the output voltage is a million times bigger than the input. Right? So write that. Yeah? All I want you to have is V out is gain by V. Huh? Gain is A, yeah. A open loop is a little circle. Right? Open loop is a little circle underneath. Please. Right? So the open loop gain is that, right? Nice. One more note. Note that your output, yeah. Note that your output, your V out is never. Actually, let me write like this. Note that your V out note that your V out is between negative V supply and positive V supply. Your value can never be bigger than the supplies. Right? Your V out trapped between those two values. And we'll deal with what will happen if it gets clear. Huh? It's kind of, but it just could get more. Yeah. Good. No, it will just kind of force itself to go back to the lower.
So where was it?
So like it reach too high and then pull it back down to where it's supposed to be. Huh?
You don't know what it's like.
No. Alright, so what is the example here? The up-arm that we just drew, right? I'll leave the diagram out, right? What is here? In figure 3, the up-arm has a gain. Up-arm has a gain of 3 by 10 to the 5. The up-arm has a gain by 3 by 10 to the 5. That's the gain of the up-arm. Huh? No, for this example. For this example, the gain is 3 by 10 to the 5, and the supply is plus and minus 15 volts. All right. So what is here? What is the output voltage for the following inputs applied between the inverting terminal and the zero? Right. So what is here? The first input value we have to work with is 10 microvolts. How do we find V out Divish? V out is what? Open loop gain by the input. Gain is how much? 3 by 10 to the 5. VN.
No.
No.
10.
10.
10. Oh, now.
10 micro.
Same thing.
Right.
Minus 6.
10 micro, right? How much is that now?
Three by 10 to the minus 2.
Okay. What's that again? 3 volts, right? Oh, look at that. 3 volts. Right, but we have a slight problem. We have a slight problem. Look back at your circuit. Look back at your circuit. Where was the input connected? On the negative end. You're saying that? What does that terminal do here? Invert. So it could be. It was positive. Okay, we now become negative. So your answer here, and even if you're seeing that here, your answer will be minus. So including negative here, including negative sign here, right? Okay, copy it down. Huh? Right, more favor, and now it's pretty next to. Right, look at the two values there. Actually, pay attention now.
We like it. I mean, but
Alright.
my brain. My brain. You bring it down. It's never the week.
Work out also not please.
Let's see.
Oh.
It's have a good relationship.
minus. So all your inputs inverted, right?
Yeah.
All your inputs.
All inverts in here, all inverts. Any of them exceed about any of them exceed 15? Minus 15, sorry.
Oh, are we checking the last one?
That's the point, right? Yeah. Yeah,
Y'all done? Yeah? So B and C, now it's 18 and 40, right? So that'll be minus 3 by 10 to the 5.
It's
Because
minus
it's negative.
Yeah, because of the inverse, you're putting negative by the game.
Oh, okay, like, you know, we could just switch the sign at the end, so it'll be C three.
Alright. How do you minus reach here then?
What evil time?
What's
It can be negative.
like without the minus.
Yeah, but you have the minus after.
Or should it be something like that?
So I just added my help, don't get all wrong, because I just follow you. This is why I just stop following you.
Again, so Pag, he was what? How much?
5.4.
Yeah.
Minus 5.4.
Oh,
And last one,
minus
Minus
12.
12.
right? All those values okay?
Yeah.
All those values fall in the range?
Yeah.
Alright, let's move on. To be sure you okay?
Yeah.
You like?
Yeah, she said. She was sleeping.
Alright, let's go again.
How many people?
Next one here. Use these values instead.
It's the same
Same game. Same inverse in here. Look at this example here, B, C, and D. Very easy. We just trying to make sure you understand what to do.
I don't understand what I know.
One basic formula that you can.
Okay. Yeah, so I'm not, but also, no, I'm not.
It's the same gain, right? You're using the same gain minus 3 by 10 to the power of 5.
Jesus Christ. It's a problem. Again, I have a big number.
Remember, it's V in your final.
Big number. Oh, that's the out.
Yeah, it's V in your final, divided to give you as V out.
Right.
Look at the first example. Look at the first example. Right, if V in is the V out divided by V.
So negative.
Still negative, same upon V.
Yes.
Yeah. Yeah. Oh, it's very bad.
Six.
Right, well, what you got for the second one?
1.85.
Look at the signs there, yeah?
Negative.
Look at the signs.
Yeah, negative 1.8.
5.4 by minus. Sorry, you got
Negative
minus 1.8 by 10 to the. Right, that's the input, right? Do the same thing for all of them.
I think that we like to see.
Right. Easy.
Let me change font here. Yeah, we got those values, just check and see. Division, look at those values. Look at those values.
Yes.
Because you got those values there. Yeah.
Yeah.
Right. Look at the next step here, right? What you see here, right? What is next set of values here? What's these here? Work out those please. Same game. Same open loop game.
What's I feel really high.
Without them saying.
And you actually.
Let's see, let's again.
Leave it, just leave it, I'll show you, that's it. Deviation work them out?
Yeah.
Don't deviation, work out, let's change this slide, hurry up. Whatever you get, leave it, right? I'll show you how to fix it.
In this line.
Same gain, right? Same gain.
It is.
Got you done?
Yes.
This one? The next one, huh? Hurry up.
Exit to the negative. So you have to.
Same input, same change the size. That's why I put in negative on the gain there for you. Deviation, what's yours, David?
It's got.
But the negative, the change in one time.
Leave
Leave it, I'll show you what to do.
Why get to phone right and it's taking. Oh, well, yeah. That way.
This is 10 to the
Minus.
That's my normally.
Which one?
First one is micro.
First one is micro, the next two are millimeter. So micro is 10 to the minus 6, millimeter.
Let's say minus 5. Oh, well, then it's minus.
Because of the.
No, that point.
Look at how long it is. Oh, I think that's what I wanted to push. Can we push it on that before you-
It's too much, right?
Maybe that's why it's supposed to see that.
Already picking up.
I don't know, you can't change it.
But I was single,
Why?
You'll find it.
single and now inside, it's a visual along. Single and single, second.
Again, more raised in the weekend. 10 to the minus. It's more right, just- Even so. I do so.
Yeah, it has to be me.
I do so. This is like the easiest.
Let's go. Right, so you all recognize that some of the values are too big, right, or too small, right? Right, when that happens, that concept called saturation. That's something we should explain.
So like,
Okay, next step. Oh, you understand? Understand? Okay, you understand? Right, V out, so V out will begin minus 3 by 10 to the 5 multiplied by 70 by 10 to the minus 6. How much you all got? Minus. Right, that value too large, right? Because our inputs, our output has to be between minus 15 and 15. So here's what is happening. Anytime the value goes beyond, you're bringing it back to the closest. So for example, it's at minus 21, you're bringing it back to the closest value. So the actual answer that you'll get is minus 2. Right? This here is for saturation. whenever whenever the theoretical value is larger, or the calculated value is larger, we go back to the nearest theoretical value. That's okay? So this value, you don't want this value. Well, you're not going to get that value, you're going to get minus 15 volts. Well, look at the next one. Right? When in positive, 1 by 10 to the 3, negative 3. How much you all got there?
300.
300. That value is too large, right? So when you reduce it, it comes back to what? 15 volts, right? Okay? It comes back to 15 volts. Next one, it will overshoot again. So the answer will be minus 15. Next one will overshoot again. So the answer will be 15 plus 15. Right. I have a little question. What causing that? What's your thing causing saturation? Think about it first.
Yeah, what a good into it.
Right. The input controlling the saturation, right? So if the inputs stay within a certain range, no saturation. So I have a little question for you now. Aaron, could you identify that value or that range of values that would cause saturation? I don't want to have to, right? I don't want to have to keep going and calculating this. I want to be able to look at the inputs. I want to be able to look at the inputs and figure out if it's going to cause saturation.
Like 0 to 60 might.
How I do that? Anything between
Anything be negative.
oh yeah.
Alright. Based on the inputs, the output as 15.
Right.
The input as the output of minus 15 and 15. I basically found that.
All right, well, close it. Well, that's technically it, but what is here? In order for you to work out the input, the range, the highest and the lowest, using just rearranging the formula and find for inputs. Input is what? Gain over, sorry, supply over gain. So plus and minus supply over the open loop gain. Right? So your supply is plus and minus 15, your gain is 3 by 10 to the 3 by 10 to the positive 5. How much is that? How much is that? 15 divided by 3 exponent 5. How much?
50 microvolts.
50 microvolts. Yeah, 5 by 10 to the minus 5. Okay with that? So any value bigger than 50 microvolts, as you can see here, or any value smaller than minus 50 microvolts, saturation. Everybody okay with that? Yeah, you'll show up on it. Yeah. All right, just make a note of that, please. Look at here. Maximum input voltage that does not cause saturation. In fact, write this down. Saturation it cause saturation it cause just little summaries, little snippets I need to get, right? Saturation occurs when the output voltage is bigger than the supply. You understand why? Why you expect an amplifier to give you a value that is not being supplied to you? It don't have the energy for that. Right? It don't have the energy to give you something bigger than 15 volts or smaller than negative 15 volts. That's okay? What do you say? Okay. Yeah, the formula.
See that?
What's called factory? Huh? What's called factory? Huh? What's called factory?
What's it called?
Yeah. What is called it? Okay, and very and truly the input, right? This formula should really be max and min input, right? But that's basically what I find. Now I have a big challenge. The challenge is I want you to get a graph of output versus input. See if you can figure out what the graph will look like. But inputs in our graph. I want you to try to figure out. So I've given you a graph. I've given you V out. I've given you V out versus V in. Right? And I want you to try to figure out what the shape of that graph will look like. V out versus V in. What will it look like? And based on everything we just looked. What will it look like? Always automatically input the lens. No, but think about it. Are there inputs? All give that different outputs. Okay, they are inputs. Zero, we can do. Okay, that's nice. So you original. Think about the input. Just look it up. Just look at it. Kind of. Yeah, close. Repeat that something. Can be out. No, you're we have negative, and you have negative yes. The graph of yeah. No problem, that's right. You probably be like, the word, it'll probably be that's what practice, right? You'd be like, the word, it'll not so my like, I don't like it, it's something like that. Don't think about it, always.
That's what we, that's what we done. Yeah. Why? What? No.
What did they say? Yeah. Right, it was, let me catch that. I guess, yeah, myself. Close it. Close. Way on. Way on. Well, you have to be joined. Should we, we have something. Right, so we close it. You all have the idea, so it's shaped like a kind of, right? But whenever you have a negative input, the output is what? Now, positive, right? And if the input positive, the output negative. Just watch back a graph. That's confirmed. It started that. It started that way. Yeah. So watch back a graph. Yeah. If it's an input in a graph. So in negative. So what you see? The graph is generally shaped like this. The graph in general. Right, the graph, whenever it's negative, it will go up that particular value. It will look like this, right? But this will happen when the input goes beyond a particular value. This, everything here that you're seeing is saturation. So this, sorry?
Oh, yeah, 'cause it's big up.
What it includes, applying terminal was a good example, was a good approximation there. Right? But your graph will look like that.
Let's see.
But remember, this only holds for
Inverted graph.
inverting. What would a non-inverting look like? Look it up. What I mean, what the other way? A correct side. Yeah, saturation is the horizontal bar. But if you give an example, it's terminal velocity plot. Huh? Yeah, that's the inverting. Negative giving it positive. That's what the inverting of one looks like.
Oh, dude.
No.
That's what the boy said.
Who's that?
You said that.
So I never said that. I thought class would start at 2 o'clock.
Oh.
Anybody have to wait? If you finish one, we had to wait. What you?
No, it's like, this.
I said.
Well, it's not that I'll start.
Yeah.
No, but I don't mind, I don't know, we have to check one little stuff, so I don't mind.
It literally said it had to leave.
But then I said, come, sorry, I see.
But it's no, we wouldn't have passed it and activity.
Yeah, well, technically, we said that.
Alright. Take a look at it here, try number 4, number 5, and then we sketch the graph, and then we take a break. Oh wait, no break, because it's finishing before o'clock.
No, we already told it before the meeting.
Huh? Finishing 4, no break. Try this here.
No, division I think about leads.
Yeah, division, one just come this way, and one just come that way.
Please put in with and I'm not about to. It makes more sense.
So we know it's 15 already.
Yeah, plus and minus 50, work it out already. Oh yeah, we'll put all the pictures. Okay, this one.
So we're living on a like
Again, right? But it- Oh,
Oh, the school of a second, I'm going to.
yeah.
Yeah, I think.
Oh, yes, it is.
Yeah, outside.
I never realized.
Good idea. You get a real sick of the books.
I have my book.
Huh? Oh, good. Check on the school going one.
My school is doing.
Yeah.
My principal really like that one.
Well, I book drive, but it'll just come and sell that.
We could even give us textbooks.
Not.
None.
And Michelle's not there again. Keep it up. Michelle's a real rough. When I was there, it's a real rough. I had you up here, we had a team. Yeah, should make it big. I just, you see, I'm like, you can have it found there. But when the house it, was it up with this guy? She has Bibles or that.
I have one iPad. I have two each. I have that. Yeah.
Right, what we got for the next one? What we got for, oh, sorry, the first one was how much again?
Nine. It was 15 plus or minus.
Plus or minus 51.
volts. Oh, you only it's 50 microvolts.
50 micro, right?
Yeah.
Next one is plus and minus 9 over 3 by 10 to the 5. How much is that?
3 by 10 to 5.
Plus and minus 30, right?
30.
You already have it and put in the answer like that, right? And last one is what?
So how you get it?
Yeah, I know.
15 divided by 3 exponent 5.
Yeah.
And you will get 5 by 10 to the minus 5, which is 50 by 10 to the minus.
Oh, you put it right.
20 microvolts.
We have to wait.
Yeah. What's the last one?
20 microvolts.
20 micro.
Every single give us a best to the end. Very complicated.
Okay.
I want to drop.
Right, so you recognize that when the supply drop, the maximum and minimum input drop in as well, right? Look for my name in that. What kind of competition over?
So that's very helpful about it. We'll do more, wasn't doing anything else.
All right, next one. Last two and then take a break. No, no break. Next one, last two. No break.
I don't know.
Last two. These are nice little development questions, right? I want all of the handouts like this,
Yeah, sure.
I guess.
With questions.
With questions like that, but not past people, that can't pass
Yeah,
it.
that's good. That's good.
Like this,
Yeah, like a textbook or like a textbook.
like a workbook.
Yeah.
This one is not much, so I won't write. Leave this one. Like, very good one. Huh? It's module 2. Well,
No, the games was my instrument.
yeah, well, this is module 2. Module 1 is with statics, electricity and manual.
Because we're in Bucky talk, rule and anything. We like, I put it in context and I did context.
And it comes twice in a row, it comes all, it comes Jan and June.
Yeah, but we getting two for start, we didn't know what I was. If we do this, we two more couple, we're doing two more couple, we're doing that.
Oh,
We didn't know what I was. Now that's like last question.
I did not
I was
know.
like, oh, good.
Yeah, we didn't expect that.
Alright, sketchy graph, do number 5, sketchy graph. And the rate all going might finish. Too short, anyway.
No, you.
So all we did today, we did intro into our parts, right?
You know what we are saying?
Huh?
It feels part of the class.
Well, we do border.
Oh, that was it? Oh, like that?
No, the last one was hard. Half part. Like you can see 20.
Oh, it's so sad already. So we have a class. We will read it before it starts. So when he teach the teacher, and they don't like math, so he real smart. But when it comes to exams, that's what we like. So we can read off the attack.
What are you getting to? I mean, see, sorry.
Yeah, distinction. We didn't get married. We real smart. Like I didn't know we didn't get married. So the maximum is 6.
Huh?
Let's say EH plus 6 microvolts applied to another.
So 6 micros is input. Right? They give it.
The answer.
Well, that's just the input, it's not the max, that's the input they give.
What's the name?
Oh, the season.
That's if they ask the market, then answer that. What should they ask one? What is the output voltage? Right, so they want you to find it. They want you to find V out. How you find V out again?
B in by A.
V by, so that's 2 by 10 to the second.
By 15.
By, no, by 6.
6 by 10 to the.
But look at the first case, the supply is plus 15, right? Sorry?
Now prepared.
The thing is, now we got streaming all the time.
The same meter is now shooting.
We're shocked, we'll probably guess it. You can see. I think it was working all the time. Ah, you have to watch it. Too much.
Yeah.
Yeah, we can.
Hold on.
Yeah.
So how much do you want to let go? What? I will do it. And then that's happened. Try to fix that. Everybody have your own school. This guy is school. This guy got some.
Now, let's get to do that. I'm going to want to show you. We I
Yeah.
Nobody will see that.
It's not his content, that we reached. It's not.
Oh, what's going on? I see that.
Nah, I go play.
Yeah, we have cameras.
I think it's class.
I just see in school. When they walk in our school, they're taking on error.
That's cool, else there.
Right, how much you all got here? Right, will that cause saturation
Yes.
in part A? No, it valves.
You say with the output is.
Yeah, because 12.
Yeah, but I thought I put it wrong too.
And what will happen in the next one,
Yeah, it can be saturated.
right?
6 volts.
So that will approximate the 6 volts. Okay? Are you okay with that?
Yeah.
So the one underneath here, just make a note that that is saturation.
Yeah.
That one.
The next one, I got this was the big.
It's just 6.
No. Come on. Take it next to
Right, and then to the graph. Last one, to the graph.
Or yes,
Right, do the graph, and then we are. No, no.
So we're finding maximum amount of minimum. First, if we don't believe you,
I know.
Oh yeah, sketch a graph where you can do values.
there is no changes because you do last. We're going to find maximum minimum. Hey, here's what was going on. You know how you got confirmation. Yeah, you came back on a good job. This is very good. Right up there, right here. Right up there, right. Anything when I go to you, they're like, oh, oh,
You guys,
you don't hear run. I'm not as quick. We asked for. Oh, he's a bit far right here. You asked me, but no.
That's right. It's like, guys, this is like a conversation.
But he asked us to look like right now.
Nobody, I was in business,
No, I will put. No problem.
You didn't too much to class, but very bad.
Yeah, watch yourself.
You really maximum output. There's two.
No, not good. No. Friday, Friday. Friday, I like Friday. Actually, better because only Monday. I can get a raw. There's 6 in the
Or we can start with the athletic. Here we go.
Oh, so I'll become a dance stand.
You look at she living fast. Shall we 3 hours? 4 hours. That's my being on.
Yeah.
Sit up at a fix up.
Yeah. I'm curious. Yeah.
My kids are.
Yeah, that's right.
Yeah, can't be there. Everybody.
Your sketch graph, when you're gonna here. You should know what the shape is, right? Just to get it balanced, to get it like that. Oh yeah, sketch graph. We can go. Like that.
Yeah, but you can.
You might have to go, right? That's not wrong.
Yeah, I get good, sir. I know too.
No, but I just fast it. Because you might think, okay. Okay.
I love it, baby.
Again, we group.
Michelle, pizza.
Yeah.
No, they didn't specify and they give you a positive value.
So no, I'm
Why do we equate in values? In these values. So we share get through the graph.
So what's my graph on that? That's right.
Wait, rather than come back. What are the things
Six. So we gotta pick like 6.
Yes, I did not need for it to stay calm.
I didn't stop thinking of like What's it? Yeah, we do like minimum serious. Your max output is 6, right? It's 7.
It's 6 months.
It's 8, 6, 1, 2.
Right, plus and minus 6 over 8 by 10 to the 5. How much was that?
That's
So 7.5 by 7.5 micro.
Right, 7.5 micro. Right, so I will average 6, 8 plus 7, 7.5 is about here. 7.5 here. And then yes, from here and from here. All right. So that is it. Oh no, we have one more thing. The thing in the layer, remind me. Good job.
Where is it?
I have one more thing.
No,
So wait.
like 6 and
7.5. Remember, you have to work out the input in the layer. That's the max and min input, 7.5. That's the max and min input, 7.5.
Speak better as body. Right?
Yeah.
Yes, it's
What?
Hey, you know where the best group number?
Six.
Six. There's 7. You will see that.
Are you okay with that?
Yeah.
All right. Last thing, get some notes. So we have application, but before we do that, all right, just take a look at this here. This here, these are the assumptions of the op-amp. Every op-amp is assumed to behave like this. In an ideal world, op-amp, the open loop gain is infinity. So here what it's saying, right? What it's saying here is that I given you an op-amp and I given you 0 input, right? And I want infinite output. What's infinity over 0?
Undefined.
Infinity, right? So basically, in an ideal world, I am giving you nothing, and I want everything.
Aerobic.
Right? Right? So that's basically what the ideal assumptions are. Okay. So here what it's saying, it says infinite open loop gain, which does not depend on the frequency of the input. I'll explain that frequency for just now. Right? This implies that the op-amp is not saturated. Use as an amplifier rather than comparator. You'll see what comparator. Infinite input impedance simply means this. Impedance means the resistance. So if the input impedance, if the resistance here is infinity, how much current or voltage will be able to enter? It's 0, right? And then 0 output impedance means if the output is 0, then how much will come out? Everything, right? Right? So those are the 3 assumptions. Infinite open loop gain, right? Infinite input impedance. If you don't like the word impedance, you can use resistance, right? But there's more impedance in these devices, right? And 0 output impedance. All right? Those are the 3 assumptions in an ideal case. But in real life, these are the values. In real life, very high open loop gain, the values are around a little more than 1 by 100, which is 1 by 10 to the 5. Input impedance very high, around 10 to the 6 to 10 to the 12 ohms. Output very low, about 100. The sad thing is you have to know those values. Because the question can ask you, what is an approximate output impedance? You have to know it's 100. All right? So you have to know these values. All right? Last thing, and I will go through this, but I will do this in the questions next day. This is a gain versus frequency graph. All right? So let's say we have a gain of 100. That gain will only work for a particular frequency, range of frequency. I'm sorry. It only work for a particular range of frequencies. And that red line shows the range. The range is from 1 to this value here. That's the range. That's called your bandwidth. So bandwidth is the range of frequencies. Okay? But I want you to notice something. Look at 100 and look at bandwidth. Look at 10 to the 4 and look at bandwidth. What you all recognize?
I gain less.
Lower the bandwidth. Right? So the higher the gain, the lower the bandwidth. So ideally in an op-amp, you don't want too high a gain because the frequency that the op-amp will work for is too small. So you want to go like in the middle around here. Okay? Right, there's one slight problem with this, and I'll explain it next day. This is not a linear scale. You realize that? What's the value? 10, then 100, then 1,000. It's not even. It's called a non-linear scale or a log scale. I want to show you how to read values, right? It's a log scale, right? So we have to be able to read values over. Because the value is too big. All right. So we'll stop there for today. Next day, for those who want to read ahead.